Hi, I'm Lana Jarmer, a strategic energy management coach. We all depend on our building automation system to run schedules correctly for lighting, HVAC, and occupancy comfort. Well, these systems rely on accurate internal clocks to maintain proper scheduling. But what happens when the BAS clock drifts out of sync with the actual time? Well, in this scenario, we'll highlight how a 2-hour delay leads to significant operational inefficiency, premature system startup, wasted energy, and unheated spaces during occupied hours, directly impacting staff comfort and productivity.
The first clue came from exterior lighting. Instead of shutting off around sunrise, the pole lights and wall packs stayed on until 9 a.m. Inside, it was just as bad. The HVAC wasn't starting on time, leaving the building too cold on winter mornings. Maintenance staff explained that 3 separate circuit poles, wall packs, and walkway fixtures were all scheduled through the BAS, and that the system had a photocell that should also prevent the exterior lights from operating during daylight, so something wasn't adding up. At first, the lights looked like a photocell issue. The BAS showed the photocell binary input point was on, but it also read faulted, which meant that there was a problem with the input point status supervision circuit, and as a result, the lights were following the schedule only. Well, that explained why they weren't responding to daylight. But what about comfort? The coach asked when the HVAC schedules were supposed to start. And the BAS showed a 7 a.m. start time, but the spaces weren't warming up until 9 a.m. Then the answer appeared. The BAS system clock isn't working correctly. It was 2 hours behind. Even though the wall clock read 11:42 a.m., the BAS read 9:42 a.m. And every schedule in a system, including lights and HVAC, were delayed by 2 hours. The BAS clock drifted 2 hours behind somehow. That meant exterior lights were shutting off late, burning unnecessary energy. It also meant that the HVAC systems were starting late, leaving staff cold in the mornings. The photocell fault was part of the problem, but the root cause was the time drift. Without accurate time, even the most advanced BAS logic can't run schedules correctly. Once the issue was identified, the solution was straightforward. The team reset the BAS system time to match actual local time. They also noted that the photocell sensor would need replacement to restore its role in the program. When the clock corrected, exterior lights shut off soon after dawn as intended, and HVAC schedules aligned with occupancy. Staff walked into comfortable conditions again, and energy used dropped right away. The issue highlighted an important, persistent strategy. Always check the BAS system time. Even a small drift can cause a significant waste in energy and comfort complaints. Ensure to include a time verification step and seasonal maintenance, especially around daylight savings time changes.
Sometimes the issue isn't a faulty component or bad programming. We've seen it plenty of times when the building automation system clock just isn't synced properly. If the system time is off, even by a little, it can throw off schedules and impact both comfort and energy efficiency. So before we dive into diagnosing or replacing parts, check the BAS clock. If it's drifting or misaligned with the actual time of day, correcting it can get everything back on track. The quick time check and adjustment can save a lot of hustle and restore both comfort and savings. Thanks for tuning in. Catch you on the next one.
Thank you for watching this Energy Trust of Oregon video. Check out the other energy-saving videos in this series by using the QR code.